Okay guys, I'm working the area perimeter and volume quiz that I gave you guys to work as a group. So we're going to talk about it and what's got to go on here. First off, I'm going to read this to you. Your family is building a house and needs to plan out the backyard landscaping expenses. You need to fence in the backyard with a privacy fence. So we're going to do fencing in the backyard. We're going to lay down grass sections called sod. Okay. We're going to apply a layer of soil, and that's called humus, under the sod in order to smooth out any areas that are raised or lowered, and build a pathway. That's the final thing. So build a pathway that leads to and encompasses the pool. The pool, shed, and garden area have already been built, so you don't have to worry about those. They're already built in the backyard. They don't need fencing. They don't need sod. They don't need humus or paving stones. The pool itself. Now, we are going around the outside of the pool with the paving stones. So the fence builder gives you a preliminary quote of blah, blah, blah. We're not really going to worry about the numbers right now. So we kind of just looking at what are the four things we do. The fence wraps around the outside of the yard, beginning at either side of the house, okay? The landscaper is giving you a quote of blah, 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 blah. The sod will cover areas. Sod will cover all areas of the backyard not already covered by another structure, and inside the privacy fence that we're building. Okay, so, and you were told to spread the fertilizer mix 1 inch thick across the entire backyard. I should note that will be in the same area as grass. So that's the same area as the sod. Okay. You'll be adding a 2-foot wide walking path made of stone from the back door going to the pool. And they're going similar circular arcs. Don't worry about the fountains. They're going to be added later, so that really doesn't matter. They also continued the path all the way around the pool. So it's around the pool, and it's going to change to being 4 foot wide. Okay, use the picture below and the following information and find the measurements indicated. Now, this information here is going to be important later, but right now I'm not really concerned about numbers. I just want to get concept. So let's look at the picture. And in the picture, I'm going to go through and I'm going to add things and take away things as I see that I can. So as I zoom down a little bit, here's the backyard. And of course, we've got the house down here. Okay, this is the house. That would make this area right here the back door that leads out the path. That we're going to change. That path is going to be the stone path that goes all the way around the pool. So there's our bricks. That's what we're going to be doing for bricks. If you notice, let's go ahead and cut these into pieces. We've got a half circle here, a half ring actually. This is a ring, okay, which basically means I've got a circle and a circle inside of it. I've got the same thing over here, and 2 half rings make a whole ring, okay? Between the 2 of them, I end up having a whole ring. Well, if you notice, I've got the same thing here. I've got a whole ring. So this is a half ring. And this is another identical half ring. So together, they make a whole ring. So it looks like we're going to be dealing with some circles there. Okay, I'm going to erase all this. All right, and now in the center of the pool, it looks like we've got, going through that same idea, it looks like we've got a rectangle minus a rectangle. You probably remember this shape. We talked about it when we did the football field. If you don't remember what this shape is called, together with the circle ends, we call this a pill shape, okay? But we're probably only going to be concerned for paving the stones on that section and this section here, but that doesn't mean we don't need to find the pool, because we will need to find the pool when we take it away, because we're going to cut this out of all the area so that I can find the grass or sod. So once again erasing that, we're going to need to find these things. So it's probably best to look at cutting these up into pieces. So I'm going to start by cutting up as many shapes as I can. And I see that we've got a circle here, the half circle here. We've got some rectangles here. And I'm going to start copying. Let's see, if that's 30, that's 30, and this is 30. Okay. This is going to be 30. This is 4 here, so 4 and 4 and 4. I believe this is 16 here. Okay, and then as I move around, it looks like I'm going to have 8 down here, copy across. This would be 17. And let me move the picture a little bit. Up here looks like that's going to be 4. And so it starts seeing some stuff that I don't necessarily know. Let's see, this is 6. But it looks like there's a triangular region out here. So I'm going to go ahead and pull that out and look at this. It looks like there's this triangular region out here. And so I'm wondering how long this triangle is going to be. Well, I see up here that this says 81 from end to end, and that is actually measuring from there to there. Okay, I know I didn't mark that well, but it is measuring all the way. So if that's 81, and here I have 40, 6, and 30, then I can subtract it. Well, 81 minus, let's see, 40 would be 41, minus 30 would be 11, minus 6 means that this section here has to be 5. Okay? That has to be 5. So if this is 5, I think we can kind of do the same thing on the other side over here to find this piece. It says that we've got 68 here, and if I scroll down to the bottom, I can see that 68 reaches all the way down. And on the left-hand side, I can see that it's 80 for the entire length of that side, which means that this section of blue over here has to be the 80 minus the 68, which leaves me 12. So that's going to be 12. Now, if you notice, I believe we've got ourselves a nice little right triangle. So I can go through and use Pythagorean's theorem, and we'll do that here in a minute to find that final piece. So let's move down. Everything looks good here. So let's start taking these apart one by one. If I go to the pool, and I want to work for the area in the pool, we already said that this is 4. So that means that the total length across, this total length across, is 24. That's going to be the 16 plus the 4 plus the other 4 gives me a total of 24 across. That tells me that the small circle has a radius of 8, and the large circle has a radius of whatever half of 24 is. So that would be 12, right? So I'm just going to draw that down here. That distance is 12. Okay, so now I've got a small circle with a radius 8, a big circle with a radius 12. I've got a, let's see, that's 16, that's 30, that's 4, 30, 30, 4. Okay, so I can go through and I can find all these little sections. This is going to be the area of a rectangle, which is length times width, which is 4 times 30, which is 120, and all of these measurements were in feet. So that is 4, let me write that better, times 30 feet, which is 120 feet squared. 120 square foot. This is the same up on top, so it's also going to be 120 square feet. So what about the interior pool? Well, let's see. If I look at the area of that rectangle, it's also going to be length times width. And in the interior pool, the length is going to be 30 feet again. But the width is going to be 16 feet across. So that's going to be 30 times 16, which is like 3 times 16, which is 48. And so that must be 480 feet squared. So I'm going to go ahead and put that inside as well. So this area is 480 square feet. Okay, so if I look at the small circle, I'm going to do it as a whole circle. So I'm basically going to make a ring over here. Here's the large piece, and here's the small piece. Now I do want to find both areas because I'm going to need to know the area of the small one whenever I deal with the yard. But let's see. The area of the small one, which has a radius of 8, is going to be pi r squared. The small circle is pi times 8 squared. So that's going to be 64 pi. 64 pi. So this area is 64 pi. That makes this area, no, pi, 32 pi, and this area is 32 pi. Okay. But the area of the big circle, which has a radius of 12, okay, that is going to be the area of 12 squared pi. That's going to be 140 pi. So this is the area of the whole thing, 144 pi. Okay, so if I want just the area of the ring, if I want just the area of this ring, and that's going to be that stone path we're going to need at some point, okay, I'm going to look at taking 144 and subtracting away 64, okay? So 144 minus 64 means my area is going to be, well, 144 minus 4 is going to be 140 minus 60. That's going to be 80 pi. 80 pi for just the ring. All right. So I've got 80 pi for that ring area. So let's go back and put all this stuff in. So I've got 120, 480, 120, 32, 32, and 80 pi. Okay. And I'm going to erase some of this as I go. This 20, 480. And the other bit was 80 pi, which tells me that each of these is going to be half of that. So that's 40 pi for this half of the ring and 40 pi for this half of the ring. I'm just keeping it all in this picture so you guys can keep track of it. All right, so we went through and did the pool. Now let's talk about the two semicircles here. This is the path, and this path is going to be laid with bricks, and so we need this area here. We need to know how big of a path we are laying with bricks. We're going to just assume that this was a semicircle. We're not going to worry about that little dot at the corner that got lost there. And so let's take a look at the two semicircles. Really what this ends up being, if I put them together, is once again I've got a ring. Okay, and I've got a ring that has an interior diameter of 16 which means that its radius is once again 8. Now, the hard question is, what is that ring's width? Well, they told us that the width of the path was 2. Let's go back and see where that is. All right, so that is a 2-foot wide walking path. 2-foot wide walking path. Okay. So that means that really I've got a radius of 10 going to the large circle. So if I'm looking for this area here, which I am, I look for that area there, I need the area of the large minus the area of the small. That's how we get that ring. So the area of the large equals pi times 10 squared. Now where did I get 10? Well, that was the total 8 plus 2 to get that length 10. And then the area of the small equals pi times 8 squared. And so when I subtract that, I'm going to end up getting 100 pi, that's 10 squared pi, and 8 squared is 64 pi. And I subtract those, and I'm going to get 36 pi. 36 pi for the area. Okay? And that is going to, I'm going to go back to that previous page. So that means that this blue section is 36 pi. But since this is only half of it, that means that each half is going to be 18 pi. So let's go back to our picture. And scroll down. I'm going to write 18 pi. And 18 pi. Now, you don't have this ability, but well, that's a little too small. I can, there we go. Take and drop that in there. Yeah, right, okay. So that's 18 pi for each of those. Okay, and together that makes 36 pi. But I'm keeping track of them separately so that if I need to go back and look at any of this, I can as we go. So the next section that we're going to do is the garden. Okay, so the garden. This 32 is the diameter all the way across. So really I need to know the radius, okay, and the radius is going to be half of 32. So it tells me that is 16. So the area of the garden is going to equal to pi times 16 squared. But is it really? I mean, it's only a half of a circle. So I don't have the other half here. That goes down here. So really, I need to divide this by 2. So that means that I can say, oh, hey, 16 divided by 2 is 8. And 8 squared is 64, right? Wrong. Do not do that. There we go. So, I do not cancel 16 with 2. The exponent here comes before, right? Please excuse, my dear Aunt Sally. Division is this division, right? It's much later than the exponent. So I'm going to do 16 squared first, which is going to be 256 pi over 2, which is 128 pi. Right? We definitely want to keep leaving these pi's in there. I know they seem confusing and stuff, but they're much more accurate and easier to use later on. 128 pi's. And these are all square feet. I should be putting those in. Feet squared. What I should have done was not kept such a big tip on my pen so that I could draw nice and fine. I'm going to pause for just a moment, guys. So I was just changing my pen size here. So let's move on. We got the garden. Now the shed. This one should be easy, right? Fun. That's the area of the shed. Oh yeah, that's nice. A little bit cleaner. Is equal to length times width. So that's going to be equal to 11 times 15. Oh man, once again, 11 feet times 15 feet. There we go. So 11 times 15 is like the 10 times 15 plus the 1 times 15. So 10 times 15 is 150, plus 1 times 15, which is 15. Add those together, and this is going to be feet times feet, so it's feet squared. That's equal to 165 square foot. And let's go put that in our picture. So this is 165. Okay, now the house. So we're going to chop the house up into pieces. It looks like chop that off there. And if I go and look at the entire shape, let's step back and look at the entire shape. There's an important piece to catch it. When I look at the entire backyard, I have a large rectangle. Okay, the large rectangle being this massive rectangle going all the way around. Okay, undo that. And as I zoom down, look, the rectangle would continue on right there. So I don't really care how much house is down there. So I really just need to stop here at this green line. So I'm going to erase, don't care, erase my green line. And I'm going to see that all I really needed to do was connect this. And so I'm going to find the area of these two pieces here. Delete this here. Okay. And so let's go back to our house. So we really don't need the whole thing. We just need to figure out these two different sections. So this section here, area equals length times width. Once again, so that's going to be, the width is 8 and the length is 17. This is 8 feet times 17 feet. And that's going to be, well, it's 8 times 10, which is 80, plus 8 times 7. That's 80, plus 8 times 7 is 6. Feet squared. So adding those together, I'm going to get, what, 136 square feet? Okay, and then the house is also going to be length times width. The question is, how wide is this house? Well, we know this is 20 tall, so that's easy. But this is 32, and this was 17, and this is 9 here. So I'm going to add those together, and I'm going to end up getting that the area is equal to 20 times the sum of 32 plus 17 plus 9. How much that is? So that's 32 plus 17 is 42. 49 is 58. Okay, so that's going to be 20 times 58. Which is basically going to be 2 times 58. So 2 times 50 is 100. 2 times 8 is 16. So that's 116. But don't forget that extra 0 from being a 20. So it's 1160 square feet. Add Mr. Conaway for this feet here. So 1160 square foot. And let's go back and add that to our picture. So 1160 square feet. And I'm going to erase this because we don't need that there. And this section here is what was it, 136 square feet. Okay, let's see what we have. It looks like we got this right thing. Well, we got a couple little outliers here. We've got this little bitty box up top, this one, and we've got this little triangle here. And those have to be removed as well because they are encroaching into our yard. So if I move down and take a look at everything else, it looks like we've got all of them except for that. Oh yeah, and the really big one. The really big one is the whole thing. So we can do that. The area total of the fenced-in backyard is equal to length times width. But the length is 80 and the width is 81. So this is going to be like 80 times 80. I can do 80 times 80 and then 80 times 1. Add those together. So 80 times 80 is 6,400 of them. And 80 times 1 is obviously 80. So this is going to equal 6,480 square feet, which is the total square footage. But we're going to take away things like this little guy right here. We're going to kill him, if you will. We're going to take away this one right here. And the pool, and the shed, and the garden, and some of the house. So let's go figure out those last two little guys. This is 4 by 6, which is easy. Area equals width. 4 times 6 is going to be 24 square feet. Okay, and then the triangle, now that one was a little trickier. We had figured out that this was going to be 5 and 12. And so the area of a triangle is 1/2 base times height. These are base and height because this is going to be a right angle corner. And since it's a right angle corner, as soon as I get this done, I'm going to get 30 square foot. I'm going to go ahead and do Pythagorean's theorem on it, where this is C, because I want to know what that third side is, because I'm going to need that for my fencing. So this is going to be 25 plus 144 equals C squared. Add those together, and that's 169 equals C squared. So I'm going to root both sides. Square root. Don't forget the plus or minus. Okay, so that's going to be C equals the square root of 169 is 13. Now, do I need the plus and minus? Well, let's see. The plus sounds good, but the negative, we don't have negative distances. So we know that the answer is going to be positive 13 here. Let's go back and let's put those into our picture. So here I've got an area of 24 square feet. Here I've got a distance of 13. Okay. And I have an area of 30 square feet. 30 square feet. Okay, you know, some people might ask, was this going to be covered in grass? And yes, all of this is. Everything here is covered in grass, okay? Everything that is not the garden, the shed, the pool, or the walkway, or the house, or one of these little cutouts are all covered in grass. So now we got to go through and we got to start adding some of this up. So let's talk about doing the perimeter of this thing. And if you will, give me a moment and I'm going to go through and clean this up and I'll be right back. Okay, so I've tried to clean this up for you guys. I know that it's smaller, but I needed some room to work out here to the side. So first off, we're going to talk about the fence. The fence is basically the perimeter. So with the fence, they did tell us that way back in our first, let's see if I can find that slide. Way back in our first slide, they said that the fence was going to be covering, let's see. Yeah, right there it is. Okay, so the fence wraps around the outside of the yard, beginning at either side of the house. So that's the key point there, is it starts at the house. So if we go down and go back to this one, and that means that the fence starts here and goes around, following this back. So it looks like I need some more measurements. I guess I left one off earlier. I don't know how long this section is here. So the entire section was 81, right? If I take away the 7, the 32, the 17, the 9, that's all the left-right measurements. So 81 minus those, I believe we're going to get 16. Do that in my head just real quick. 32 plus 17 is 49, plus 9 is 58, plus 7 is 65, and 81 minus 65, yeah, that sounds like 16. Okay. So, let's see. We've got 16 foot here. If I'm doing the perimeter, I'm going to say that's 16 feet. 16 feet. Plus, we've got the next, so that takes out this one. The next section is 68. So 68 feet. Plus, the next section there was 13 feet. Plus, the next section, which was 30 feet. And a little tricky spot that a lot of people forget, okay? We got to remember that this was 4, and we went around it. So that's 4 feet, and then 6 feet, and then another 4 feet, and then a 40-foot section. Okay? And then an 80-foot stretch. And then the final 7-foot stretch. Okay, and I'm going to go through and I'm going to add these together, and there's easy ways to do this. For instance, 40 plus 80 is 120, plus 30 is 150. Let's see, plus 6 and 4, that's another 10, that's 160. Let's see, 7 and 13 is another 20, so that's 180. 16 and 4 is another 20, so that's 200, and plus 68, that's going to be 268 feet. And yes, in the problem, it does talk about linear feet. And that's really just linear feet is the same thing as feet, where square feet is the same thing as feet squared, and cubic feet are the same thing as feet cubed. So a linear foot is just a one-dimensional measurement of feet. So our perimeter for the fence is going to be 268 feet. And if we go back to our problem once again, our problem asks us how much is the total thing going to cost. So as I look down here, it says the fence builder gives us a preliminary quote of $16 a linear foot to build the privacy fence. So let's go back to that problem, and that's about right because I think I paid $14 a linear foot on mine just a year or two ago. So if I go back to this problem, I currently have how many linear feet, but to get the cost, it's going to be equal to the length, okay, times the price per foot, price per linear foot. So that's going to be the 268 feet times the $16, and that's dollars, so that's the unit there. Per, when it says per, that means divided by. So it's really $16 divided by feet. And you notice what happens to the feet. They divide, they reduce to be 1, right? So it's 16 times 268. And the only unit left is dollars. So the answer is going to be in dollars. The dollar amount is 16 times 268. Oh, dear God, you're going to have to help me here. Okay, so you can't help me because he's not really here. So this is going to be 2,680, so 6 times 268. Well, 6 times 200 is going to be 1,200. 6 times 60 is going to be 360, and 6 times 8 is going to be 48. So now I got to add all those together, those dollars. So 2680 plus 1,200, that's 3638.80. Plus 360 is going to be 4180 plus 60 is 4240 plus 48 is 4288. I might have made a mistake there, guys. Please use your calculator and check, okay? Trying to do all this stuff in my head. Going to make mistakes. Okay, so we've got the cost of the fence. All right. So guys, you can pause here, copy this down. I'm going to have to erase because we've got to move on to the next piece. And the next piece is going to be the amount of area, the sod, okay? We will be doing the humus, but it'll be helpful to find the amount of sod first because that is going to be the same as where we're going to put the humus. So the area we're going to sod, that'll be equal to the total area minus the pool, okay? What else is it going to take out? Minus the shed, okay? Let's see, minus the garden, minus part of the house, not all of the house, but part of it, the part we found, minus the walkways, minus the little cutouts, okay? I think that takes care of everything. So we already know that the area of the total was 6480. So let's do that. We're going to say the area that we're going to sod is going to be 6480 minus the pool. And I'm just going to add all these things together here. So I'm going to say minus 480 and feet squared. Why didn't I put that in there? Feet squared. Minus 120 feet squared. Minus 120 feet squared. Minus 32 pi feet squared. Minus 40 pi feet squared. Minus another 32 pi feet squared. Minus another 40 pi feet squared. And if you want to know where I got all of those, I got them all right here. There's the 120. Let's see, we started with the 480. 480 and two 120s, okay? We've got the 32, the 40, the 32, and the 40. Okay, so that's all included in. So now I need to take off the garden. All right, so minus 128 pi feet squared, minus the house, 136 feet squared. So let's go ahead and scratch those. That's that one and that one. Okay, minus 1160 feet squared. Here's the rest of the house. Okay, let's take off the shed. That's another 165 feet squared. Bam. And let's take off the cutouts. 24 feet squared minus 30 feet squared. So that's going to be that one and that one. What do we leave? What do we leave? Did we miss anything? Did we miss anything? Yeah, we did. We missed the walkways. Minus 18 pi feet squared minus 18 pi feet squared. Some of you are probably saying, Mr. Conaway, just deal with those pies. Put in that 3.14. No. You can do this so much better without dealing with that 3.14. Let's just keep the pies together. So let's go through and put all these together that have a pie. Okay? And they're all negative, so when you put a negative plus a negative, it gets more negative. If I lose 40 and I lose 40 more, then I've lost 80, right? Okay, so 40 and 40, that's going to be 80, okay? 32 and 32, that's going to be 64. So let's see, this is going to be 80 plus another 64, so that's a negative 80 and a negative 64. It's like adding, so you end up getting a negative 144. Is that right? Let's see, 64 plus 80. Yeah, I think that's right, negative 144. And a negative 128, so that's going to be negative 244, plus the 20 is negative 264, plus the 8 is negative 272. But let's not forget these 18 pies down here. So 272, 8 would make that 280, 290, there we go, 308 pies. So this is going to be a negative 308 pies. I know that you can probably calculate it faster than Mr. Conaway. But let's do the 6480. I'm just going to leave that there. And so let's find this other piece. So negative 480 minus 120 minus 120. Let's see. 480 minus 120, that's going to be 500. Minus 620. Okay, after I do that one. So that's 620. And I'm going to go with the easy ones first. 620. There's 650. Let's see. 650. And 1160. 1160 and 650. That'll be 1760 plus 50 is 1810. I like 136 and 24 because I like 6s and 4s that go together to be wholes. So that's going to be 140, 160. So 1810 plus another 160 is going to be 1970. And then another 100 is going to be 2070 plus the 60 is 2130 plus the 5 is 2135. Please check me. If I'm wrong, fix it. Okay? You guys can fix it without me. So put those together, 6480 minus 2135, and I'm going to get 4480, 4380, 4350, 4345 minus 308 pi square feet. So that's square feet. All right. So you could round now. This would be a good time to go ahead and make it round. And you're going to get 4345 minus 308 pi 3377, approximately 3377.39 square feet. Okay, I'm going to pause that while I check. All right, and I did make a mistake, and I know you've been yelling at me to fix it. This was 2235, and I guess that makes this 4245 minus 308 pi, which ends up being this 3277.39. So take 100 off there. Okay. So we've got the square footage. Now we go back to our question. Our question said, how much is the sod going to cost us? And it says the landscaper's giving you a price of 40 cents a square foot to lay the sod. So we go back to our problem. We say, look, the sod is got 3,277.39 square feet, and we're going to do 40 cents a square foot. Okay. Now I'm going to plug that into I'm going to leave that. The calculator has a perfect version of that in the calculator. So I'm going to say the cost equals the area times the price per square foot. So that's going to be this 3277.39 square feet times, my bad, equals, times $0.40 per square foot. And that's, once again, where those square feet cancel out. And the answer is going to be in dollars. So that's going to be on. I'm going to go back. And if I use the answer button in my calculator to get that nice non-rounded version, 3277.39 whatever else, times 0.4 equals, let's see, 1310.96. Okay, but that begs a question. Is he going to charge me for a partial square foot? Is the sod guy going to lay half of a piece of sod and call it done? And no, he's not. And we don't want him to short us. So if we take this 30.39 off and we round it down, then we won't have enough sod. So no matter what, we want to have more sod than we need. So instead of ordering 3,277 square feet, we need to go up one and call this 3,278 square feet, because he's not going to give us a partial square foot. And so that's going to change this to an 8, right? And then we're going to multiply by 0.4. And we're going to get 3278 times 0.4 equals 1311. So 1311 and 20 cents. That is our actual cost for the sod. Okay. And now we're going to go back and work on the cost of the humus. All right. And I will come back to this, and I'll probably put it on another video after I've summed up everything off this video.